So yeah, so welcome, and this is the lead code hard problem. Basically, what here I'm assuming that you have already read the question. So what he was trying to do is he will give you an array of elements, so that you need to split that array into d parts. This is what he actually mean. You can read this question and yeah, let's just have a look. Basically, what he was trying to do is he has given us 65321, and he is asking us to split this array into two parts. If you have made a partition over here, then you need to take the maxi of that each split and you need to add the summation. See, the maxi of this left side split is 6 and the maxi of this right side split is 4. And what is the summation? That was 10, right? Right. If you have decided like 654 3 2 1, right? If you have made a partition from here, then your maxi will be 6 and your right side maxi will be 5. Then what is 6 plus 5? That is 11, right? You need to minimize the sum. You need to minimize the sum. To minimize the sum, the optimal answer will be if you have made a split until this last element, then the right side split will be 6 and the left side split will be 1, right? Then we can get 6 plus 1 as 7, right? So in order to tackle this problem, we are using the partition dp. So how to use the partition dp and what is the main institution like? So we are going to have a look. See, since he has given us 6 comma 5 comma 3 comma 2 comma 1, let us forget about the splits. Let us understand what is actually going behind this. So can I say that I can't make a split over this because my left side split contains zero array elements, and he said that you have to finish at least one task every day. So he was telling us that your each split should contain at least one element. Your each split should contain at least one element. So if in order to satisfy that condition, you can't make a split at the zeroth index. Can I say that? So so what we will try to do is we are going to start iterating from the 1th index, and we will take the maxi and we'll take the sum. Cool. We'll take the maxi and we'll take the sum. Initially your maxi will be this element. Initially your maxi will be that element, because in any split you need to consider that element, because the split can start from here. Right? So initially you have to consider your maxi as 6 and your summation as 0. Make sense? So you currently you're standing at the 1th index. Now, if I try to make a split on this index, then what it will become? It will become like this, right? So if I'm making a split, you need to add this left split maxi, right? So I'll add that into my summation. Now that will be 6. Now what will be your maxi? Your maxi will be your current element. Why? Because that is the previous maxi split. So you need to update that maxi. Now your maxi will become 6 comma 5. And now you'll move again to the second index, and let us assume that we are not making a split. We have already made a split, right? Let us we assume that we are not making a split at the second index. Then what you need to do? You need to consider the maximum of these two elements. What is the maximum? See, if my second element consists of 9, If my second index is containing 9, then if you're not considering, if you're not trying to make a split, then you need to update your maxi from the previous maxi split. From the previous maxi split, you need to understand this point. So I will update my maxi that has 9, right? And I'll go, and now you're standing at the index 3. And what if you are trying to make a split over here? If you are trying to make a split over here, then your maxi needs to be added. Your maxi needs to be added in your summation. That is 6 plus 9 is equal to 15. And your maxi should be updated to your current element, which was again 3. Because it is the maxi of the previous split, so you need to add into your summation. So what you will do over here is, like, you go on keep on iterating like this. You'll keep on iterating over like this, and 6 comma 4 comma 5. So now at the last index, if you are trying to make a split, if you are trying to make a split over there, then the previous maxi, what is the previous maxi? That was 3, right? So you need to add that into your summation again. That will make 18. And your update your maxi as current element, which is again 1, right? But again, this is one of the point that you need to notice. After you're going out of the bounds, you need to consider this is also one split outcome. That, so if you are out of the bounds, can I say that you finally need to add that maxi into your count? Because this one has to count. You need to count that one. You need to count that one, right? If you have made a split like this, we need to consider this. We need to consider that split maxi also. So what if, let us say, like, if you have made a split like this, if you have made a split like this, can I say that my first maxi will be 6? See, if you are making the split, you'll add the current maxi to your summation, and you'll update your maxi to 5. And then you keep on iterating, and you'll keep on updating the maxi. Then it will be 9, right? Then your final updated maxi will be 9. And after you, if you're moving out of the bounds, you need to know that is also one subbar split. That is also one split, one outcome of the split. So you need to add that maxi into your summation. That will be 15. That will be 15. If you have made a split, if you have made a split at the 1th index, right? So this is the main institution behind this. So in order to tackle this, we'll use the partition DP. So let us understand this. Now we'll take the test case that he has given us, which is 6 comma 5 comma 4 comma 3 comma 2 comma 1. And you need to split the array into two splits, right? Two parts. So in order to split the array into two parts, can I say that I need only one single split? I need only one single split so that my array will break into two parts. Make sense? Yeah. So what I will do over here is, I will take three variables, which is indicating my I. Yeah, here I'll write, which will be my I, which will be my maxi, and which will be my D. I'm gonna take these three variables, and we need to start iterating from our 1th index, right? From our 1th index, because since at 0 we can't make any split over there, it'll lead to violating the condition. So initially your I will be 1, and your maxi will be 0th index's element, that is 6. and your D will be uh, your D will indicate the number of splits that you need to make. The number of splits that you need to make. In order to split the array into two parts, you need to make a single partition, right? You need to make a single partition. So we need D minus 1 splits to split the array into D parts. So that is your I, maxi, and D. Now let us say if you are if you are making a split at the 1th index, if you are making a split at the 1th index, you're going to add your previous maxi. You're going to add your maxi of that element, uh, the maxi of that current element, and you'll update your maxi to the current element, which is again 5, right? Which is again 5. Since you have made a split, the D will become 0, right? See, here we had made like this, right? Here we had made a split like this. So I'm going to add my previous maxi, which is 6, and I'm going to move my pointer. I have made a partition at the 1th index, so now I'm going to move my pointer to next element, and I'm going to update my maxi as 5 of this my new split. And since the partitions are over, since I have made a partition, I'm decrementing my D to 0, right? What if you haven't made any partition? Then then what will be that? 6 comma 5 comma 4 comma 3 comma 2 comma 1, right? If you are standing at the 1th index, if you are not making any split, that means you're moving to this, right? So your index will be incremented, and you'll take the maxi of your current element 2, which is again maxi of 6 comma 5 will remain 6, right? Since you're not making a partition, your D remain as it is, which is again 2 comma 6 comma 1. Make sense make sense So now you'll again come to 2 comma 5 comma 0. See, we have already made a partition 6 comma 5 comma 4 comma 3 comma 2 comma 1, right? We have made a partition and we have added that maxi to our answer, and we are with this. And now you're standing at the index 2. Now we doesn't have any partitions left with us. So what we can do over here is we'll just take the maxi of our current element, which is again you'll just see 6 comma 5 comma 4 comma 3 comma 2 comma 1, right? If you're standing at the second index, you try to, since we haven't we are not left with the partitions, we'll move to the next index and we'll take the max of 4 comma 5, right? Max of 4 comma 5, it's again 5, so we'll send the 5. And since we are not making any partition, your partitions will remain same, that will be 3 comma 5 comma 0. Now you again see 6 comma 5 comma 4 comma 3 comma 2 comma 1, right? Now you're standing at the third index, which is this. Since if you haven't any partitions left with you, you can't you just take the maxi with that current element. What is You'll move to the next index and you'll take the maxi of the previous element with the current element, which is maxi of 5 comma 3 is again 5. And since we are not making any partition left with us, we'll pass the D as same as that. Then it will be 4 comma 5 comma 0, right? And again now you'll similarly you'll go to 5 comma 5 comma 0, and then you'll go to 6 comma 5 comma 0. And now this is one of the important part, right? Because since you are, see, I'll write here 6 comma 5 comma 4 comma 3 comma 2 comma 1, And now you have reached out of bounds. Now you have reached out of bounds. Now can I say that you need to return the maxi of the split? Since we have already added the previous maxi split, you need to send the maxi split of that your answer, which will be 5 of that split. So if you're going out of bounds, you'll just return the maxi. What is the maxi? That is 5. So you'll return 5. So you'll return 5. So this will return 5 again. This will return 5 and this will return 5 and this just until this. I'll just quickly erase this. Yeah. So you keep on. So that will return you 5 and this will return you 5 and this will return you 5. So what is 6 plus 5? That is 11. So the right recursive tree will get you 11. Now you need to calculate similarly for the left part, which is 2 comma 6 comma 1. If you complete this, you'll just take the minimum from the right side and minimum from the left side. So the minimum of those both sides will give you answer. So I'll just explain you with the code. See, first of all, if you are going out of bounds, and you check if there are splits that I need to do. If there are splits that I need to do, see, if 6 comma 5 comma 4 comma 3 comma 2 comma 1, since we need to do d minus 1 splits, right? We need to do d minus 1 splits. So that is what I was sending over here. See, this is your index that you need to start from the 1th index, and you'll pass the array and you'll pass the dp and you pass d minus 1 splits. That is the number of splits that you need to make. That is the number of splits you need to make. And your maxi will be, see, and again I was taking the maxi. I was not just taking the maximum element. I was just sending the index of that maximum element, which is 6. Because why I was doing like that? If we are going to send the maxi, we need to initialize our maxi maximum element. That will take extra space, right? So instead of that, what I was doing is like, I'm going to send the maxi of my previous element of that index. I was sending that index, not just directly maxi. Actually, I have said in that explanation part to understand it, right? So you'll get the maxi. So see, if your d is equal to 0, then what it is saying, if you are, see, for the first example, your d equal to 2, I will send 1. I will send 1 to my function, right? I will send 1 to my function, and that one split is already get over at first index, right? It will be finished at first index. And now if you move out of bounds, now you need to check that you have already completed all the d minus 1 splits. Then you can return the maxi. Then you can return the maxi of the split, right? So that is what I was returning, my arr of maxi. And again I was saying that my maxi is the maximum element index, not the maximum element. So you'll see that your dp states will be I, which is your index, maxi, this is the maximum element index, and d, this is the number of splits that you still need to do. And if it is not equal to -1, you'll return that. See, pick, if you are picking that element index, then you are making a partition at that. So what we were trying to do, see, I'll just erase, yeah, I'll just erase, yeah. Now see, initially you'll initialize the pick as some maxi value, since we need to take the minimum value. If you are picking that, you need to take that maxi element. See what you are doing over here. If you are making a partition 6 comma 5 comma 4 comma 3 1, you will take this element, so you're adding this, right? So that is indicating my arr of maxi, and you'll call the function by incrementing the index and by decrementing your split, because you have already made a split over here, and you'll send the I. What is I? That is your current maxi. See, you have updated, now you again updated your 5. What is your 5? That is your current element. Instead of sending my maxi element, I was sending that index, I was sending that maxi index. So what is the case that if you haven't picked, then you simply increment your I, and you just pass your array dp same, and the splits will also be remaining same, and you'll check the maxi. See, that will be, if you are splitting 6 comma 5 comma 4 comma 3 comma 2 comma 1, now if you are standing at this, I will have the 1th index with me, and you need to take the maxi of these two elements, right? And you need to take the maxi of these two elements, which is 1 and 2, and you'll check that. That is the condition that I was checking. Whatever the maximum element is, I was just passing the index. If my current element is greater than my maxi, I was just updating my maxi, and I was sending that index. If it is not lesser than that, if my maxi is still greater than my current element, then I was just passing my maxi index as it is. So just if you'll just pick, and you'll just, that is just, either you'll make a partition or you'll not make a partition. You'll just take the minimum from those two sides, and you'll just see this. If you run this, yeah, looks fine. Now we'll just quickly submit this. You see, it's working fine. So this is the main institution. Uh, just don't think like it is like a three-dimensional or something. Just simply see how can you make either you'll pick that element or you can't pick that element. What are the conditions that are changing if you are picking that element, and what are the conditions that you are changing if you're not making a partition over there. You just need to observe those two things, and you can solve this problem easily. So if you understand this, just please do like and share and subscribe, and please do comment and let me know.